Have you ever wondered how astronauts repair and maintain their space equipment miles away from civilization? In the vast, silent expanse of the cosmos, there are no roadside assistance or quick fixes. Space repairs and maintenance missions are a testament to human ingenuity, carried out under extreme conditions and unique challenges. Astronauts battle against time, limited resources, and an unforgiving environment. Join us as we journey through the top 5 most challenging space repair and maintenance missions. Our journey begins in 1965 with the Gemini 4 mission. This was a groundbreaking mission that saw astronaut Ed White perform the first American spacewalk. Imagine stepping out of your spacecraft, tethered to a lifeline, with nothing but the vast expanse of the cosmos around you. It was a daring feat and not without its trials. White had to contend with a bulky suit that was difficult to maneuver in. The lack of gravity posed a unique challenge. Every action had an equal and opposite reaction, causing White to spin or drift at the slightest touch. Communicating with mission control was also a hurdle because of the static-filled radio connection. Despite these challenges, White successfully ventured into the uncharted territory of space repairs. He proved that astronauts could work outside their spacecraft, a prerequisite for future maintenance and repair missions. This mission marked the dawn of space repairs, setting the stage for future missions. Fast forward to 1993, the Hubble Space Telescope needed fixing. Now, this wasn't just your run-of-the-mill repair job. We're talking about a telescope that was floating about 340 miles above Earth, capturing images of the cosmos that were simply out of this world. The Hubble had a bit of a shaky start, you see. Once it was launched, scientists quickly realized that the telescope's primary mirror had been ground to the wrong shape. This was a serious problem, as it caused a condition known as spherical aberration, which blurred the images taken by the telescope. The Hubble, once hailed as the greatest advance in astronomy since Galileo, was now being dubbed the Techno-Turkey by the media. Enter STS-61, the first mission to service the Hubble Space Telescope. This was no small task. The mission would require 5 back-to-back spacewalks, a record at the time, with astronauts needing to replace the telescope's solar arrays and install a new camera, among other tasks. But the most crucial part of the mission was the installation of the Corrective Optics Space Telescope Axial Replacement, or COSTAR, a device designed to correct the flaw in the Hubble's primary mirror. The astronauts involved in STS-61, including the likes of Story Musgrave and Catherine Thornton, showed not just remarkable technical skill, but also incredible bravery. Working in the harsh conditions of space, they faced potential dangers such as extreme temperatures, radiation, and the ever-present risk of micrometeoroids. But they were undeterred, maintaining their focus on the mission at hand. After a grueling 11 days, the mission was a success. The Hubble's vision was corrected, and it began delivering the breathtaking images of the cosmos we know and love today. STS-61 wasn't just a repair mission, it was a mission that breathed new life into the Hubble Space Telescope, paving the way for decades of astronomical discovery. The successful repair of the Hubble Space Telescope was a testament to human ingenuity and bravery, and it continues to serve as a shining example of what we can achieve when we dare to reach for the stars. In 2013, the International Space Station faced a critical coolant issue. It was during Expedition 38 when the crew discovered a malfunction in one of the station's 2 external cooling loops. This was not just a minor hiccup. This was a key system that helps dissipate heat from the onboard equipment. Imagine, if you will, a computer server room floating in the vastness of space, overheating with no way to cool down. The stakes were high, the clock was ticking, and the pressure was on. The solution? A series of intricate spacewalks, performed in the harsh and unforgiving vacuum of space. The task fell to 2 astronauts, Rick Mastracchio and Mike Hopkins. Their mission was to remove the faulty pump module and replace it with a spare. Simple on Earth, but in the zero-gravity environment of space, it was a task of monumental proportions. Each move was a ballet of precision, agility, and concentration. Remember, they were not only battling a critical technical issue, but they were also facing the dangers of space itself. But these were not just astronauts. They were problem solvers, engineers, and above all, explorers in the truest sense. Armed with their tools, training, and an unwavering resolve, they stepped into the void. The repair was not a single day's work. It stretched over 3 spacewalks, each lasting more than 5 hours. The astronauts had to work with bulky gloves in a weightless environment, dealing with tiny screws and complex machinery. The margin for error was virtually zero. But they did it. Despite the odds, the unforgiving environment, and the critical nature of the problem, they succeeded. They replaced the faulty pump, restoring the cooling system and ensuring the continued operation of the International Space Station. Despite the odds, the Expedition 38 crew managed to fix the coolant issue, demonstrating the importance of problem-solving skills in space. This event stands as a testament to human ingenuity, bravery, and the indomitable spirit of exploration. It reminds us that in the vast expanses of the cosmos, it's not just about reaching new frontiers, it's also about maintaining them. As we look towards the future, robotic missions are becoming more prevalent. The vastness of the cosmos beckons, and with it, the increasing need for space repairs and maintenance. But the challenge of the void is not for the faint-hearted. It demands a new breed of explorers, ones made of metal and silicon. Robots. Robots, unburdened by the physical limitations of humans, are ideal candidates for space repair missions. They can withstand extreme temperatures, work in zero gravity without fatigue, and are impervious to the harmful effects of cosmic radiation. But more than their resilience, it's their precision and tirelessness that make them invaluable. Already, robots like Canada's Dextry and NASA's Robonaut are assisting astronauts aboard the International Space Station. These robotic aids are performing tasks ranging from routine maintenance to complex repair jobs. The potential is enormous, but it's not without challenges. The complexity of robotic missions is immense. From ensuring reliable communication links to programming autonomous decision-making capabilities, every aspect demands the pinnacle of technological prowess. And then there's the issue of cost. Developing, launching, and operating robots in space is a pricey endeavor that requires substantial investment. But as the saying goes, necessity is the mother of invention. As we continue to push the boundaries of space exploration, the role of repairs and maintenance will only become more critical. The future of space repairs, it seems, is in the hands, or should we say, the mechanical arms, of robots.